Yeah. So hello everyone and welcome back to the session on your security with respect to your operating system, what we were discussing. So today's topic, what we are going to discuss here is something relevant to program threads. So in the previous session, we have discussed about in security, we have discussed about the different scenarios. So scenarios in the sense nothing but what are the different type of means what is the main purpose of requiring this particular security? That is what we have actually discussed it. And apart from that, we have also discussed exactly what are the different kind of things that do exist here, like where exactly we need to provide security, at which levels we need to provide security, that we have discussed in the previous session. In today's session we are going to discuss about program threads. Means whatever the that whatever the applications we people are running in our system, those are nothing but what we can say is nothing but it's a program, isn't it? It's a program. Like for example, if people are in, you have installed a WhatsApp application in your software, I mean in your Android mobile operating system. Now, within that mobile system, what is that application is actually developed? How that actually that particular program has been developed? I mean, sorry, how that particular application has been developed or designed is nothing but using programming, isn't it? Some set of programs has been written, and using that program, that particular WhatsApp application has been designed. Same way, you can consider your Instagram, your Facebook. Everything is nothing but means whatever within the system we are executing right now, all those are nothing but done or developed using something called as programming. The programming languages what people are learning here, like C, C++, Java and all those comes under into that particular scenario. Now in this particular session we will be discussing in this particular session we will be discussing about program threats. Means those applications whatever we are running within our system, there is a possibility that that particular programs are getting infected by several different kind of infectious softwares that we do have, or infectious programs that we do have. Something like viruses, we basically call it as, some people call it as malwares, some people call it as trojans. Okay, all these things comes under into this particular scenario. So we are going to discuss them in this particular thing. So first, in the first one, we already discussed about something called as security problems, right? Now we are going to discuss about here something called as program threats. So today's concept is totally relevant to this particular concept called as programming threats. So what are the different program threats we do have, that we are going to discuss here. So coming to the general description here, these particular program threads usually have different names. You know that, okay, within a particular program. Okay, let me show you. Yeah. So you know that within a particular system, let us suppose you consider your operating system. Okay. So within the operating system, when you're working on this particular system, you know that kernel is the one which we have as the heart of a computer, isn't it? And apart from that, we have some other application. What is the other applications we do have here is nothing but your what we call it as processes. Because you know that whenever we want one particular task to get executed, definitely we require this particular process, because the process is the one which is created, and using this process we are going to perform the operation. And in order to perform that operation, we definitely require something called as kernel, because he's the one who will be interacting with the hardware and make our task whatever we wanted to do successfully, do it with the help of this particular thing. Now here what he's saying is that there is a possibility that when we people are creating these processes, when we are want certain tasks to get executed, so definitely some breaches, like certain program may become infectious. Some programs may become infectious here. Infectious in the sense nothing but that is something like a virus kind of thing that has been developed by the hackers or cracker. You know about hacker and cracker, right? In the previous session we have discussed it. Hacker is the one who will try to get unauthorized access to our system and the resources that are present in our system, and try to modify the data that is present in our system. That is what comes under here. So here also coming to program threats, there are many different names are provided, many different type of variations we do have with respect to programming threats here. The very first one what we are going to discuss here is something called as Trojan house. Okay, Trojan horse, this is one of the popular thing. Now, okay, what exactly this works on? Well, here Trojan horse is something like it is a code segment that actually misuses the environment. Okay, what do you mean by code segment here is, I will explain this with the help of a small example. Let us take your text editor. I think you people are very familiar with this particular text editor, right? You people have an idea related to this particular text editor. Now, within this particular text editor, you people have written some program. Now, here, what exactly happens here is that this particular program, whichever you've written, this particular program is getting modified by the hacker's program. The hacker or the cracker, whoever we are having here, this hacker or the cracker, he will try to modify, he will write a code, write a code in a text editor, and that he will try to infringe with the program which we people are trying to execute it. Something like you can consider like you people are running a C program .c. So you know that program .c, where exactly people are writing this program.c in a text editor, right? If you're not using any kind of something called as tools, then definitely you people will be using a text editor. You will simply write the program and store that particular file with the .c extension. So here what this particular hacker is doing, he will also use same text editor in order to write the code, and that he will be mapping to this particular thing and he'll perform the operation. So that is what he's talking about here. So that kind of thing is what we call it as Trojan horse. What exactly does it? It simply modify the existing program whichever we want to execute. It will simply try to modify that. It will simply try to get control over this particular system. Okay, so whatever the program you're writing, if that particular program is having access rights, that is what are the access rights we have? Read, write, execute. So if that particular program is having read, write, execute, now this code whichever the hacker has written, it will try to access this particular program. Once this particular program is getting accessed, means whatever the access rights that are provided to this particular program, that will be under the control of this particular hacker. Now he can do anything with respect to that particular read, write, and execute operations. And assume that within an entire system, if you're providing these particular processes, I mean, what I mean to say that within a entire, I mean, within the entire system, if you are given the permission to this, something like a Bootstrap, whenever you people open switch on your power button, your operating system turns on. So that Bootstrap also consists of something called as a program. If that program is actually getting infected, means what happens indirectly, the entire system's control comes into this particular hacker, and he can do anything with your system. Either he may destroy your entire system, or he may try to get the confidential credentials from your system and try to modify them. Okay, so that is what we basically call it as Trojan horse. Mostly these are the one which are written by the programmers that are executed by other users. Okay, like permissions are given, and that user may be malfunctioning that particular thing. And if I ask you, okay, sir, can you give a practical example related to this Trojan horse? Well, yes, we can give it. Like you people are already having a mail IDs. I think every student or every candidate or every person on this earth, okay, those who are using smartphones, definitely they have a mail IDs with respect to you their Google account, right? Now, in that particular Google account, you have a folder called as spam. I don't know how many of you seen it, how many of you watch your Google, like I mean Gmails frequently. I don't know, but if you see there is a folder called as spam onto the left hand side. When you click on that, you will be getting so many different type of advertisements. Now those advertisements are what comes under spam here. Spam in the sense those are not of perfect type. They do consist of some kind of program which is, if you people click on that particular program, it may try to harm your system. It may try to take control over your system. That's why the Google has filtered using his algorithms, and they have removed as a spam. So what you people have to do is simply have to delete it. So that is what he's talking about your spam. Okay, and the next type of programming threat that we come across here is something we call it as trapdoor. Do you have any idea about trapdoor here? No idea, I guess. So trapdoor is something like, I have been telling you people that whatever the applications we are running in our system, those applications are nothing but basically developed using a program. So whenever we talk about a program, who is actually going to develop that? So definitely a programmer is going to develop, right? A programmer is going to develop these particular programs, and that programs will be formed as a format of application. Now here, I don't know. Okay, software engineering, I think it's not completed. In software engineering, we have SDLC, software development lifecycle. Whenever you want to develop an application, we need to follow this particular cycle, software development lifecycle. The very first step in this particular thing is something called as requirements. You need to gather the requirements from the customer for whom you are developing the application, and after that, based upon those requirements, we will be designing. Okay, we will be designing that particular application, whatever it is, and then we will start the programming part based on the program. Indirectly you can say designing is nothing but blueprint. Please remember, designing is nothing but you can say this is a blueprint. Like whenever you people apartments has to be designed. Okay, so when the contractor starts developing a design, I mean, apartment constructing an apartment, he first has a blueprint of that particular apartment, and based on that only they actually design it. So then we go for programming. After designing, we go for programming. Then we go for testing. So we will be testing the program or the application whichever we have designed it, and finally we have something called as deployment. Then we will be implemented. So this is something like you people have developed the application, now you're deploying that into your Play Store so that you people can download and you can access that. And finally we have something called as maintenance. Now this is a software development life cycle which you people will be encountering in something called as software engineering. So in this I am actually focusing on this particular part. I want this second part, designing. So designer is the one who plays a very vital role based upon the requirements whatever has been gathered. This particular program, I mean designer, will be constructing the blueprint. Now when they are constructing the blueprint, that particular designer, if he is somewhat malicious person, okay, he is the one who is somewhat not a good person, then he will try to make a hole in the design. He will try to make a hole in the design. Hole in the design is nothing but loop. You can say it is a loophole. Loophole means the one which no one knows except him, because that the applications are very big and they consist of some millions of instructions. The applications are very big and they consist of some millions of instructions. Now what the user, this designer, will do is he will create a small loophole into this particular application whatever he is designing. Now what will happen with that loophole means he will be using it for his own sake, because he is the only one, the designer is the only one who knows where exactly this particular loophole is present. Okay, let me explain with an example. Let us suppose I am developing a bank account, I mean I'm in a bank website. Okay, I am actually developing a bank website for what? For performing transactions. I'm developing a bank website where I wanted to perform transaction. Now what I will do is, let us suppose the user is paying some amount, something like 8,430.40, or let us assume 60. 8,430.60 paisa is going to, so total this is the amount he has to pay. Now, what I will do is when I'm designing this particular website, I will make sure that whenever I'm getting such a kind of figure like 60 paisa, I will generally round it off. I will make it as round off. Okay, round off means how much amount the user has to pay now? 8,431. Okay, now the user has paid 8,431, but what happening here is that out of this 8,431, what is the actual amount he has to pay? 8,430.60. Now this one I will be transferring this to the bank. I will be transferring this to that particular bank. Then what about the remaining? How much amount is left? 0.40 paisa is left. Now this 0.40 paisa I will be transferring to my account. Please understand carefully. Okay, so what I am saying is that when I designed this particular website, what I did is that 8,430.60 paisa is the one which we have, which we need to pay into the bank. What did I do is I made a round figure. I wrote a program where it will take only round figures. It will not take this point decimal places. It will not take up. So definitely the user has to pay 8,431. Now the user will think that he has paid the amount 8,431 to the bank, but actually to the bank it will be transferred, the total amount transferred is 84,030.60. But what about the dot 40 paisa here? That will be transferred to my account. Okay, now you may be thinking, okay sir, you're saying that it's okay, you are taking only 0.40 paisa from that account, then no problem, no, it's only 40 paisa. 40 paisa is very very less, you people can assume. Okay, that's fine, I agree with you. So 40 paisa is nothing, it's very very less. You can say it is negligible, that's fine. Now let us suppose in that particular website for one day 10 million transactions are taking place. Assume it please, 10 million. Okay, so 1 million is equal to 10 lakhs. Okay, 1 million is equal to how much? 10 lakhs. So 10 lakhs is something I'm not sure. I'm just writing. Let's see. Ones, tens, 100,000, 10,000 lakh. Okay, 10 lakhs. So how many I'm talking about here? 10 million. So into 10. So there will be one more 0 here. So your information will be something like 3 zeros, comma 30. So three zeros, comma 30. So ones, tens, hundred, thousand, 10,000, lakh, 10 lakh, crore. Means 1 crore transactions are taking place on this particular bank website per day. Per day, one lakh, or sorry, 1 crore transactions are taking place. Now let us suppose the same kind of problem is coming with with 1 crore transaction. So within this 1 crore transaction, same these kind of numbers are coming. Assume that for every transaction I am getting 40 paisa. Now first let me convert this 40 paisa into rupee. 1 rupee is equal to how many paisa, 100. So I'm talking about 40 paisa. I wanted to know how many rupee. So what I had to do? So 40 into 1 by 100. So you remove this. Okay, this 0 and this 0 gets cancelled. So 0.4. Now 1 lakh transactions into 0.4. 0.4 is nothing, but I just converted into rupees. So 0.4 means how I can write it here? 4 by 10 I can write it up, isn't it? 4 by 10. So if I cross remove this, what is the total amount I'm getting here? 4, 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6 zeros. So this is something like this. Now for per day, how much amount I have actually stole from that particular bank? Let's assume it. Ones, tens, 100,000, 10,000, lakh, 10 lakh. 40 lakhs I have stored. You can say simply, so for one transaction, sir, you are just trying to grab 40 paisa from that account. So it's very cheap. Now per day, how much I got the amount here? 40 lakhs I am getting from that particular bank. I'm simply stealing it. That is what we call it as a trapdoor. And it's very difficult to determine this particular trapdoor. Why it is very difficult to determine here is because your application consists of some millions of lines of code, and when millions of lines of code there, it's very typical to determine where exactly that loophole is. You need to read each and every program line. Whatever the lines you people have written the code, each and every line you have to go through one by one. Then only you will come to know where exactly the problem is, and it will take a lot of time, because only the designer know where exactly that problem is, and that will not be checked frequently. Okay, sometime in 2 years or 3 years one time. So then in that 2 3 years, one day only I'm getting 4 lakhs. Assume that for 2 to 3 years, how much amount I can easily store. This is the way how these hackers actually perform the operation. Not only hackers, even you can say the one who has designed it. If he is a malicious person, he will be planning. So I hope you people are getting it. See how much different type of threats we have when we are writing a program, isn't it? And next is logic bomb. Yeah, this is something different. Logic bomb. Yeah. Okay, so what I mean by logic bomb here is nothing but here, normal transactions whatever are taking place, that will be same. Normal transactions whatever are taking place, that will be same as the previous one. But what exactly logic bomb is that sometimes when these transactions are taking place, some mischief program will be executed by the hacker. Okay, or some malicious, you can also call it as malicious, some malicious program will be executed by this particular hacker. Okay, and that is in such a way that you will not be able to detect it, because every day it is this kind of logic, means this kind of threat to the program will not be taking place every time. It is certain occasions, something like very high, when there is a in the server, there is a server here. Let us suppose during Diwali, there are a lot of sales are taking place. This is an Amazon server, and you know that during Diwali time and during festivals time, a lot of shopping will be done. At that time, during the peak time, these people will be executing this. Now, these many transactions are getting performed now, so there is a possibility one of the transaction can be misinterpreted by that particular hacker, and he may try to stole the information. He may try to perform. So that kind of thing is what we call it as logic bomb. Okay, so this only occurs during certain circumstances, not every time. So that's the reason it is very difficult to detect when this happened, because definitely if you have traces of this particular thing, then only, I mean, this hacking and all, then only you can trace it up. Then only you will come to know that someone has hacked your system. But if there is no traces of some, only sometimes it is performing that operation, so definitely that will not be able to detect. We cannot detect that. That comes under here something called as logic bomb. So going ahead, Next, what we have is tag and buffer flow. This is something relevant, and we are going to discuss much on this particular concept. This is something with respect to our programming, what we are having here. Now, stack and buffer flow is nothing but, see, whenever you people are writing a program, you know that the program will be stored in a stack. In operating system, in the second unit, oh sorry, this is a second unit. Okay, this is operating system, right? So in the operating system, in the second unit, we have already discussed about something called as stack. I don't know how many of you remember. In that stack, we have shown something like this. So here we'll be having a heap. Here we'll be storing some information here. So here we'll be storing global variables. Here we'll be storing something called as local variables. And in between, we are having a free memory. This free memory will be allocated for dynamically allocated space. For example, if people are using linked list. So in linked list, you will be creating a node. And whenever you're creating a node, you have to dynamically allocate a memory to that. So that memory is what is talking about here. Now, this is a stack, right? Now here, what the program, I mean, what the hacker is going to do exactly in this particular thing is nothing but he will try to hack this particular stack. He will try to hack this particular stack, and he will try to modify the data that whatever you're presenting into that particular table. I'll explain in the coming slide with the help of a diagram so that you can get an idea about it. Okay, so mostly this particular stack and buffer flow, what it does, it exploits a bug in a program. Means a particular bug is nothing but some kind of malicious program will be injected by that particular hacker or the cracker into the system or into the program whichever you people are executing. And what that particular program is going to do, it will try to modify the data that is present into that particular stack. Okay, so whenever you people are having, I think you people heard about segmentation. I don't know how many of you remember, already we have discussed it. Segmentation means whatever the program you're writing, main, some code. So all, this particular program will be chopped, or we can call it as fragmented. This fragmented is nothing but small pieces. So small pieces. So this particular main program, whatever we are writing in a C, this will be fragmented or chopped into small pieces. And that small pieces will be stored into the stack. Maybe one where we will be placing all the local variables. Local variables within a function, whatever the variables you're declaring, that will be stored here. Then we have something called as you people might be declaring functions. That functions we might be storing here. And then you people might be declaring global variables. So that I will be storing in a stack, global variable here. So what this particular stack and buffer flow kind of a threat, what they're going to do is the programmer will try to modify this data, the global variables, local variables, and these variables, whatever he has. He'll simply try to modify that data, and based on that, he will try to put the data, I mean, his own data into this particular stack. So that this whatever the program you people are executing, it should not be getting executed perfectly. That is what comes under your stack and buffer overflow kind of thing. Okay, so that is what he's exactly saying. So let me show you the diagram so that you people can easily understand that. Yeah, this is one of the example with respect to this particular buffer overflow. Okay, how? Let's look at it. Hash include, this is a small normal C program. Okay, hash include stdio.h, hash define buffer size 256, int main argc char. I think you people can understand. You people are good enough in C language, I guess. So char buffer. So this is the array. This is a character array. I mean array which I'm using, and the name of this array is buffer. And within this, what is the size limit I'm using here? 256. So 256 characters I can take in. Now, if the argument is less than 2, return -1. So you know that argv. What do you mean by argv here? Argv is nothing but we call it as argument vector. We call it as argument vector. And what is the main purpose of this particular vector here is nothing but during command line, you people will be giving some arguments. Okay, during command line, you're giving some arguments. First, you'll be giving a program name, and then you'll be giving the input. Now, this input will be stored into this particular vector, that is argv. Okay. Now here that's why he's saying. So argument. So here argc is nothing but argument character. This is a vector. So here argument character will consist of the list of characters whatever you people are providing it. Now if it is less than 2, he's simply asking you. So because whenever I told you in the whenever you're executing in a command line, you have to give two characters here. One this is first one, this is second one. This is input what I want to give, and this is the name of the program, whatever. So that he is checking. If the argument is less than 2, then simply return -1. Means you did not give the input perfectly. Else what is saying, simply copy whatever the data you are given, argument 1, that is this input, whatever you are given, that you just simply copy into this particular buffer, this array. And what is the size of this particular? Now, there is a problem with this particular program. There is a problem with this particular program. Okay, so what is the problem here we are having here is, assume that what is the maximum limit that this particular buffer is having here? 256, because the buffer size is 256. Now let us suppose I have given 3000 characters. Sorry, 300 characters I have given as input. Then what will happen? Can this, whatever the 300 characters I have given, can this string copy can insert into this particular buffer? Well, it can insert up to 256. But what about the remaining 4 characters which you people are giving here? Now system will be malfunctioning. This is one kind of threat. The system will not be, now this particular program will not be executed perfectly. Why? Because the buffer size, whatever you are taking, is 256. But the input which you gave to the argument vector is 300 characters. So it can take only up to 256. The remaining 4 it cannot take. So definitely this particular program cannot be performing. So what is the problem here? The programmer did not think about that. You people as a programmer should be taking care of these kind of things. Yes, as a programmer, you should be taking care of this. Okay, if I have given a buffer size of 256, I should make sure that whenever the input is given by the user, he should not exceed these many characters. He should not exceed more than 256. So instead of using string copy, instead of using this function, if the programmer has used this one, strncpy, this is a function. This function will make sure that you are not exceeding what is the size of the buffer. What is the value here is something, what is the syntax here is buffer comma argument vector 1 comma size buffer minus 1. This is the, so instead of this particular statement, this particular function, if he has used this function, whenever if any user is trying to give more than 256 characters, immediately the program will say that you are not supposed to give more than 256. Okay, you are not supposed to give more than 256. So this is the way how exactly this particular program works. You people can write the statements here, but unfortunately the programmer is not good in programming, so he has written simply string copy. So here what will happen if a customer is giving more than 256 characters, so definitely this particular program will be malfunctioning. So that is one of the biggest threat we have. Why? Because the buffer is getting overflowed, because the size of the buffer is 256 and you people are giving us 300 characters. So definitely the buffer will be overflowing it. And whenever the buffer is overflowing, definitely you will not be able to get a perfect output. Now this is the stack I was talking about in the previous slide. This is a stack. Okay. So you can see here, let's talk from top to bottom if I talk. So initially, whatever the parameters you're giving to the functions, I'm storing into this particular location. Automatic variables are nothing but he means to say all the local variables. You people are giving, suppose you people are writing main. Okay, let me show you so that you people can understand. Main int a comma b comma c. C equal to add a comma b. Okay, so printf c equal to %d comma c. This is a normal program I have written. So here these are what we call it as local variables, right? Int a comma b comma c are the local variables. Now we also call this as automatic variables, and that variables will be stored in this particular location. Now, if you see the second step here, c equal to add, what I'm doing here, I'm simply calling a function. And in this function, what are these two a and b? These are the parameters, isn't it? These are the parameters which I'm using. That parameters will be stored into this particular location. So a comma will be present here. Here a comma b comma c is present. These are local variables and these are in the format of parameters I'm sending. So that will be stored here. Then you are printing the statement. So after c equal to a plus b means this is a add, and within add you're writing int x comma int y, and here you're simply writing as return x plus y. What you're doing? Return x plus y. So what happens here? Automatic is that return means whatever the value we are getting. Suppose you are given a value as 3, b value as 4. So 3 plus 4 is 7. So this particular return will send the control back to it. So c is equal to 7. That return addresses will be stored here in this particular stack. Okay. And what about the saved point frame pointer here? This is nothing but within this particular stack. Now you people are storing this. Suppose this is the top. You know that okay. Anyhow, data structures is completed for you people, right? So you know that in data structures in stack, when you talk about insertion and deletion is done only at one point. We call it as top, and that's what it's talking about. So here whatever the values have been stored, so this will have some index 0 1 2 3 4 like this, right? Now this saved pointer will consist of those addresses. It will consist of addresses where the information is stored, where the information has been stored here. For example, parameters are stored at location, assume it check 0. All the local variables are stored in the index called as 1. The written addresses have been stored in something called as a location called as 4. So this is a way how exactly he's describing exactly in this particular scenario. Okay, this is the way how whenever you people write a program, that program is actually stored in this way into your stack in your operating system. But now let us suppose now the programmer hacker came into picture. A hacker came into a picture. Now what he's doing is he is executing this program. This is a malicious program. Remember, this is a malicious program. Hash include stdi.h int main arguments character. What exactly is doing is he is using this system call. This is a system call. What it is a system call which we are executing it, and using this particular system call he is going to what he's going to do, he is trying to get control over a shell program. Means whenever this particular programmer is going, hacker is going to execute this particular program, this will create a shell program in your system. He will be executing this program in your system. Okay, maliciously he has inserted this program in your system and it's executing this. And whenever he's executing this, let us suppose it will generate a shell program. Okay, and this shell program will be taking control of your entire system. Means indirectly he is going to take control about this particular stack whatever we are having. And now what he's going to do is he will try to replace these parameters. Whatever the parameters you are seeing here now, return address, saved pointer, all these parameters he will try to modify it. And that is the purpose of this particular threads. That is what he's going to do. I will show, okay, in the next slide I am showing you this. Here it is. So just look at here. This is a normal stack. This is a normal stack where everything is perfectly done. See, I have used that string copy in a buffer size -1. I have placed it. So buffer 0, 1, 2, so on up to buffer size -1. So this will consist of the addresses of this particular stack. And if there is a written address here, the control will be, all that details will be stored here. Now, when that previously, whatever the program I have shown that the hacker is going to execute it, what he will do is he will simply replace this data. He will simply replace this particular data with what? This one. This is his program. The program, okay, the program which has been executed, the program that is executed, that has been executed by whom? Executed by a hacker. So what he will do is he will simply try to modify the data that is present in this stack with this particular information. Did you see this? No. Means what happens here? This entire thing is getting replaced. You see this entire thing is getting replaced with no op. No op is nothing but no operation. Oh, sorry. Okay, no op is nothing but something we call it as no operation. Means he simply removed the data here and he has placed as that no operation need to be performed here. Same if you see this area, we consist of information related to buffer 0 and 1. Now this has been replaced with something called as modified shell code. Modified shell code is nothing but the program which he has actually written it that he is executing here in this particular thing. So this is the way how he is going to actually destroy this particular thing. I hope you people are getting it. Okay, so this is the way how exactly the stack is getting modified, and due to that modification what happened, obviously your internal systems will be malfunctioning it and automatically your system will shut down, or it may not be, or that particular operating system may not be working. So these kind of things will be taking place exactly here. Now going forward here, we have something called a viruses here. Next topic what we have here is virus. I think you people are very much familiar with this, right? Virus. So what do you mean by virus here is nothing but it's just a code fragment. Okay, yeah. What do you mean by virus here is nothing but this is simply a code fragment. What we have code fragment, do you have any about code fragment here? So nothing but a small piece of code. Fragment is nothing but small piece. So a small piece of code will be added in your system's program so that it can perform some malicious things in your system. What kind of malicious things? Well, that depends. Like viruses, usually what they perform is self-replicating. Self-replicating is nothing but indirectly it means to say duplication. Indirectly he means to say something called as duplication. Okay, self-replicating is nothing but duplication. So a infected file will be inserting into your system and it will be duplicating the data, that whatever the files are there, that it will simply try to duplicate, and it will try to make sure that whatever the information present in your system means your space is getting occupied more and more, and due to this what will happen, your system will finally hang. And finally at last what you have to do is you have to simply either modify it. What you have to modify is nothing but you have to rechange your operating system, because you're already there is a virus in your system. It is simply duplicating the files. Your memory is getting killed. Whatever the memory, suppose 1 TB of space is there, that 1 TB will be filled with the same file. Same file will be replicating, duplicating. So your entire 1 TB will be filled with this particular same file. So you have no other way except that modifying that operating system. You have to reinstall that particular operating system in order to overcome this particular virus kind of feature. That's the thing. In order, if you don't want to do that, definitely you have to use something called as antivirus, because it is the one which can protect us from this particular kind of viruses. Now here, this is a small code. This is a virus program what we have. Okay, this will be run by a hacker. So you can see here, this is a program he is talking about here. Okay, this is a program which will be run by a hacker. So using this program, this is a virus program. What we have is a small virus program which we can execute it, and with the help of this, we can perform different. We can make our system destroy. Okay, but only thing is, since we are you people are using antivirus, and then it will not get destroyed. That's the normal program he has given. Now, talking about virus, okay, so you may be getting doubts. Okay, sir, how these viruses are actually entering in our system? Okay, we have a term here, something we call it as a virus dropper. We have a terminology, we call it as virus dropper. Now, this is the one which will be inserting our that particular infected file into our system. Okay, infected file is nothing but it's a program, and that program is written by whom? By the user. So here this virus dropper, what it means to say that that infected file will be inserted into our system by this particular virus dropper. Now here viruses can be categorized into different file. I mean different ways. Like we have viruses with respect to a file. We have viruses with respect to a boot or memory. We have viruses with respect to your macros, with respect to your source code, polymorphism, and then we have encrypted. Furthermore, let me explain one by one. What about file here is nothing but this is a virus which will be attacking. Okay, this is a file. Sorry, this is a virus which will be attacking only files. Yeah, how they are going to attack files is nothing but simply they will be replicating the data. Means whatever the file you are having, that it will try to duplicate them. That is what the comes under into this particular file. We also call them as parasite viruses. Why do you know why we call it as parasite virus? The hacker will get all the information. It will try to retrieve all the information from your system, but still your program will be executing it. Means it will try to get the data from your system, but still your program is executing. So you will not get any doubt that your program has been hacked or the data present in that particular program has been hacked. That's why we call it as a parasite virus. Then we have virus with respect to boot and memory. Now this is going to infect the booting sector. Now what do you mean by boot is nothing but, as I told you, that we have a power button, right? In your laptop you're having a power button, and when you click on that button your operating system gets activated. Now below that particular button you are having a bootstrap program. You're having a small hardware called Bootstrap, and within that you're having a program called as Bootstrap program. Now whenever you click on this particular power button, this Bootstrap program will be activated, and then your operating system is going to be loaded into your RAM. So here what this virus is going to do is it will try to destroy this particular hardware program, whatever is there, in order to load it. So what will happen? You will keep on pressing that particular button and you will not be getting the output. Okay, you'll keep on pressing that particular button. Okay, whatever the power button is, but still your operating system is not turning on. So that is the infection what it can, this kind of viruses can provide you. Then we have macros here. Now this is a virus which is written in high level languages. Okay, not like a normal language, not in assembly language, neither in C languages. These are the one which are written in high level languages, something like in Java, like Visual Basics. We can use them, and using that we can write. Now this one mostly affects something called as your Microsoft Office. In Microsoft Office you are having so many different type of applications. What are the applications we have? The most famous most famous what we use is Word. Then we use something called as Excel sheet. Then we use something called as presentations. Now whatever you're seeing, this is a presentation. This is a presentation application I'm using you from Microsoft Office. Now these macros are actually present with this particular Microsoft Office. So whatever the applications that are relevant to this particular office, all those will have the macros running here. So whenever you people are executing it, so definitely these viruses will attack this particular Microsoft Office. So based on that, what it will do, it will try to destroy the information present in this particular thing. Something like as Word, PPT, Excel, whatever the data is there, they will try to destroy that particular data, or they may try to steal that data. That depends upon the virus, how it is executing it. Then we have something called a source code. Source code is nothing but your programming languages. You people are writing C program. So you store the program with .c. If you're writing a Java program, you're storing with .java file, right? So that files will be infected by a virus. That kind of virus is what we call it as a source code virus. Polymorphic. Polymorphic is the one. This is a virus, something like okay. The best example, do you know what I can give for this polymorphic is your coronavirus. Okay, your coronavirus can be given a best example for this polymorphic thing. Polymorphic thing is nothing but one thing existing in many different ways. Now, if you see the coronavirus, we are already have came to the first wave. Then we came to the second wave. Now, first wave, whatever the virus we have got infected, means whatever the people got infected here, that is different virus when compared to the second wave when it has come. It has what it did. It has actually changed its shape. It has changed its attacking strategy. That's the reason our bodies, human bodies, are not able to tackle that particular problem. Why? It is keep on changing it. So our body, within our body, the white blood cells, they are not able to identify that this is a virus. Why? It can simply change its shape. It can simply change its parameters. Same way here also, this is a virus which will simply change the virus signature. Every virus will have a virus signature. You know that? Every virus will have a signature. Based on that signature only, the antivirus is trying to detect a particular means virus, and based on that it will try to delete it. But if a virus signature is keep on changing, so this polymorphic virus, what it will do is it will keep on changing this particular virus signature, so that no one can try to attack this particular, means the antivirus will not be able to identify, will not be able to detect this particular virus. That is what he's saying exactly in this particular thing. Then we have something called as encrypted. Now in encryption, what is showing is this is an encrypted decrypted. So encrypted decrypted. So in encryption, what we are doing exactly here is this is a kind of a virus where we'll be performing encryption. Okay, and once it is encrypted and it will be coming into your system, this particular virus will do is it will try to decrypt itself, and then it will try to execute within your system. Since it is an encrypted one, your antiviruses may not be able to detect it, and at the same time, and remember, antivirus will definitely detect it, but if it's a new kind of virus, then they may not be able to detect it. That's the reason, so every time whenever you're installing an antivirus, you should keep on updating it. They will tell you whenever you connect to the internet that the virus database update, antivirus database need to be updated. So you should definitely update the database, because if a new kind of virus is coming, that virus signature should be present in your antivirus, which is present in your system, or else it will not be able to detect it, and that particular virus may harm your system. And the next three, four we have here, something we call it a stealth. Stealth is something like the one which will try to hide from the scanner. Whatever the scanner we have, this one, stealth and tunneling. Stealth, what it is going to do is it will try to hide itself, means from getting detected. from the antivirus. Same way, tunneling is nothing like underground kind of thing. So here also what this virus will do is it will try to hide itself from the antivirus scanner. So whenever you're scanning your file, it will try to hide beside some kind of file so that this antivirus doesn't detect it. And anyhow, these are very strong viruses which is talking about, because if your antivirus is not able to detect it, means definitely it is one of the new kind of a virus and it is something very stronger one. Then we have multi-parasite. This is something the one which infects your system, your entire system. And here the viruses will be multiple parts of the system will be included. It will be in effect, I mean it is going to infect multiple systems here. And here we have something called as boot sectors, memory and files here. So this is what you people have to consider when we are executing them. So all this like boot sector we have already discussed, memory also we have already discussed, and files we have already discussed. All these will be attacked simultaneously by these kind of viruses. And then we have armored. Armored is something like, it will have its own shield that even antivirus cannot try to destroy it. So that kind of virus is what we call as armed here. Now here I am going to show you a simple example of a bootstrap. I told you in the boot, in the power button underscore you are having a bootstrap. So how this virus is going to affect that bootstrap, that has been explained here. See here, virus, what the virus will do is, in your bootstrap, whatever the program you are having within that, it will simply copy to some position. So within a bootstrap, you are having a program which will activate your operating system. So simply what the system will do, what this virus will do is, whatever the program is present in the bootstrap program in this, it will simply copy that particular program to some location. We don't know what location it is. Obviously, it is a virus. It will know. We don't know. So what virus will do is after removing that, now the virus, what it will do is it will place its own program into that particular location. It will place its own bootstrap within this particular bootstrap. Whatever the original program is there, it will be removing from here and it will store in some location X. And here the virus related program, whatever is there, that will be dumped here by that particular virus. Now whenever you people are booting that particular system, now this particular virus related program will be injected. It will let your operating system turn on, but later on it will get entire control of your system and it will perform different operations. It may perform different operations here. What kind of operations it can perform here is like something like it may try to remove the read write disk, means your hard read write means CD or DVD writer, whatever you're having, it may not be working properly or it is not showing it in your system. Oh no, okay. Whenever you're opening your your personal computer, you will be having a CD by DVD writer. So that may not be shown there. Why? Because this virus has tried to destroy that particular file. So you cannot see this. Or it may try to boot whatever the boot program you're entering, that only it will try to destroy it. So then next time whenever you're turning on your system will never open it up until and unless you are changing your operating system. And then finally logic bombs. I think you people have an idea about logic bomb, right? I told you sometimes it happens. So without knowing you people, all the data present in your system will be copied to some other file or some other system of a hacker, and he will use that particular information to perform different operations. So final conclusion is attacks will be common and it will be keep on occurring. We cannot modify it, but only thing what we can do is we can try to stop to a certain extent. And there are something, the important topic here is keystroke logger. This is the one. This is a kind of antivirus which will try to grab the passwords and credit card numbers. If people are using credit cards, in your mobile phone, you people have stored the credit card numbers and all. So keystroke logger is the one which will mainly attack to get the passwords from your system, maybe your laptop or a mobile phone. Followed with that, whatever the credit cards numbers you have stored there, that it will try to grab it up. So this is all we have with respect to your programming threats. Okay. Okay, so why Windows is always getting hacked when compared to your Ubuntu, and this is nothing but because Windows has more flexibility, because it gives a read, write, and execute permission to each and everyone. So they are able to execute it. That is what he means to say here. So in the next session, we'll discuss about something like a software security threats, what we have. This is all about we have for today's session. That is nothing but programming threats. So I hope people have understood what are the different kind of viruses we do have and how they are going to affect our system. Okay. Thank you. Thank you for watching.